This video is over topic 45, number 15, experimental probability. So this is looking at simulating dice rolls. So rather than assuming that each outcome is equally likely, looking at what happens if we actually roll the die a bunch of times. So if you roll the die 6 times, the theoretical probability would be that each number would show up one time. It's probably usually not going to happen. It doesn't happen in any of these 3 times. Always, at least the closest it gets here is with something happening twice and something else not happening at all. And then here we had something happening 3 times, so 2 things didn't happen at all. So we're going to look at where it got farthest away from the expectation. So in these 6-roll experiments, the third experiment, a 2 got rolled 3 times. And that's 3 out of the 6. So that would be, based on that experiment, the probability of rolling a 2 would be 3 out of 6, or 1/2. In the 60 rolls, if you roll 60 times, you would expect each number to show up 10 times. And so the furthest away from that is here, the 16. So 1 got rolled 16 times on the second experiment. So the second experiment, the number of times that 1 showed up is 16. This is out of 60 rolls. So the probability of rolling a 1 based on that is 16 out of 60, which is, so this would be 0.5 in decimal form. This will be easier to compare. 16 out of 60 is 0.27. And then if you roll the die 600 times, you'd expect each number to show up 100. And this 122 is the furthest away from that. So on the third experiment, the number of times that 6 got rolled was 122. And that was out of the sample space of 600 rolls. So the probability of rolling a 6 based on that experiment is 122 out of 600, which is 0.20. Now, so the theoretical probability for any one outcome rolling a normal 6-sided die is 16.7%, or 0.167. With the 6 rolls, we got as far away as 0.5. For the 60 rolls, the furthest away that got was 0.27. And for the 600 rolls, the farthest away that got was 0.2. So those are getting closer and closer to the 0.167. Right? So even the most extreme discrepancy in the 600 rolls was still a lot closer to the 0.167 than the most extreme of the others. And so the probabilities get closer when making a larger number of rolls. So if you really wanted to approximate this, looks like you'd probably need to go more than 600 times. That was still kind of far off, 0.2. So probably a few thousand times at least would be good to get really close to the theoretical. But this could be used then if you had a die that you suspected was not weighted properly. It seems like I feel like I roll lots of 4s on this. What's up with that? Well, maybe it's just a temporary pattern that you're noticing. So you could try rolling that die a few thousand times maybe and see if the 4 is still coming up more often than other things. And if it keeps happening, then you might begin to conclude that it is not evenly weighted.